Okay, so in this video we're going to look at the equation of a circle. And we'll start off looking at an example problem where we could say what is the equation of this graph below? And pretty clearly this looks like a circle, but we've never dealt with the algebraic equation of this figure before. So let's start off actually looking at what is a circle. So a circle, sort of somewhat technically, is the set of all points on a plane that are equidistant from the center. And now, before I get too far into this, we're going to spend a couple minutes delving into some setup for the math, but then we're going to get into the actual equation, the form of that equation, and so when we get there I'll box that in. That's the critical portion of this. The rest is just important information. So what do I mean by this? Well, first off, on this plane, this word plane right here, I'm talking about two dimensions. I'm talking about something that I could draw on a piece of paper. I'm not talking about a three-dimensional figure. If I didn't restrict it to a plane and instead allowed it to be in 3 dimensions, this would actually give me a sphere, which is like a ball shape. But if I restrict it to the plane, like a flat sheet of paper, a computer screen, it'll make a circle. This equidistant, so this word equidistant means same distance. And that distance is actually going to be our radius. That's not how you spell radius. Let's try that again. Radius r. So the radius r is the distance that we are from the center. So let's go back and see that example and figure out what's going on. So again, this is going to be a little involved here, but we'll come up with a rule for any equation, and it'll be pretty procedural, pretty quick, pretty easy after that. So looking at this right here, I'm going to say, okay, well, let's find the center. And some of you may be able to eyeball it and say, okay, the center's right here. Some of you may have a little bit more trouble seeing that, especially as the circle gets bigger. So if you're having trouble seeing it, you can even draw a set of crosshairs. Say, okay, the diameter horizontally and the vertical diameter. And I can see that, okay, my center is at this point, -2, 3. The other piece of information I need is the radius, and the radius is this distance. And so we can see from here to here, I have 1, 2, 3, 4 units. So the radius will be 4. So I'll put that information over here. We have a radius of 4. We have the center -2, 3. And you can notice no matter where I go, this point here is 4 units above the center. This point here is 4 units left. This point here is 4 units down from my center. And any other point over here, this will be 4 units diagonally from my center. So any point on here is 4 units away. No matter which direction I go, if I go 4 units this way, I'm on the circle. Now, I can use that information to actually come up with the equation. So again, this stuff is not going to be necessary at the end when we get the form, but if I recall the distance formula, d equals the square root of the difference in x's, x2 minus x1 squared, plus y2 minus y1 squared. I can use this to guarantee that my distance will always be this radius 4 from this point. So I could say, all right, let's make the distance always be 4, and that'll be equal to the square root of my x-coordinate minus my x-coordinate from the center, so -2 squared, plus my y-coordinate on the circle minus the y-coordinate of the center squared. And I'll clean this up a little bit, so we would get 4 equals the square root of x plus 2 squared plus y minus 3 squared. And one last thing I'm going to do, I guess two last things. I'm going to get rid of the square root by squaring both sides. And so that will get me to 16 equals x plus 2 squared plus y minus 3 squared. And generally, when I see the equations of circles written, I see them in the other order. I see this distance squared over here. I see the squares of the differences of the coordinates on this side. So I would write this as x plus 2 squared plus y minus 3 squared equals 16. So this right here is the equation of my circle. Notice I had the center, -2, +3. I have in my equation a +2 and a -3. I had the radius of 4, and I have in my equation 4 squared, which is 16. So that leads me to the general form, or sorry, standard form. So the standard form equation of the circle, when the center is at HK, and the radius, let me actually change the color on that and use the same colors we had in the last one. So my center was in blue. Was it? Center was in purple or magenta. So center is at HK. My radius is R. And so my equation will be this. X minus H squared plus y minus K squared equals R squared. And things to stress. So notice that in my formula, I have these minus signs. So that means when I see that, the coordinates of the center will change signs. And you can also notice in my formula, I have an r squared. And so just notice this is not the radius itself, this is the square of the radius. So you have everything you need. You just need to make sure that you modify it. Looking back at our example, I had the center -2, 3. I changed the signs. Plus 2, minus 3. Had radius 4, I squared that, and I got 16. So this right here is what you would need to use to write the equation of a circle or to graph a circle. This is standard form. There are other forms. We will see one of those other forms in a day or two. However, I'm going to change that other form to this form to graph because it has my center, it has my radius. So now using this formula, let's go and see a couple examples. So in this one, let me recall that my formula was x minus h squared plus y minus k squared equals r squared. So I need to find the center. I need to find the radius. The center, again, some of you may see it right here. Some of you may be better served by actually drawing the sort of crosshairs, these two horizontal and vertical diameters, to see that my center here is 1, negative 2. And then my radius here, I'm just going to count it off. So 1, 2, 3, 4, 5, 6. So radius is 6. And again, I need to make sure that when I put this into the formula, I change signs. And I need to remember that when I put this into the formula, I actually do r squared, or 6 squared. So when I write this out, I will get, because this positive 1, x minus 1 squared plus, because of this negative 2, y plus 2 squared, and because of this 6, 6 squared is 36. And there's my equation. Now, that's if I have the circle, want to write the equation. I can go the other way as well. So let's take an equation and sketch the circle. We see something here is a little new, and we'll talk about that. So from here, this plus 3 means that the x-coordinate of my center will be negative 3. But I don't see y plus or minus anything. But recall or note that y is the same thing as y minus 0. So if I ever just see a variable by itself squared, and it's all been taken care of, it's in this standard form, I know that the center's coordinate there will be 0. So this center is at negative 3, 0. I also notice this 16 right here. And so if r squared is 16, that means r will be the square root of 16. So my radius will be 4. And I can take this information, plot my center at negative 3, 0. That center is not technically part of the circle, but it's helpful to see where I'm going. Now for my circle, I can go up 4 for my center, go back to my center. Right 4, go back to my center. Down 4, go back to my center. Left 4, and then do the best I can. If I actually had a compass out here, or we're using a different piece of software, I could sketch this really nicely. For me, I'll just do the best circle I can there. It's gonna, let me try that. So the best circle I can. It's gonna be a little bit janky, a little bit off, but I have these nice guide points here that really keep me to the right size, even if the shape is not quite perfect. Look at that lovely circle. Okay, I hope that helped out. In the description, you'll see an attached worksheet that'll give you some practice on this, and feel free to comment